Okay, we're now going to discuss a form of binary notation that's called 2's complement. 2's complement is a way of representing negative numbers in binary. Okay, so this is why I'm going to explain why it's so useful. Let's just before we get on to what 2's complement actually is, let's just consider a simple bit of binary arithmetic. That's of course 9, and we're going to subtract 8 from it. Okay, so there we go, and that's a really straightforward piece of subtraction. 1 minus 0 is 1, 0 minus 0, 0, 0, 1 minus 1 of course is 0, leaving us with the answer 1, which we know is correct. So what's so hard about that? Well, it becomes a little bit more complicated when we have numbers that aren't quite as kind to us. Let's take a different example, and let's have the binary for 33, which is that. Okay, so that's binary 33, and let's just simply subtract 6 from it. Okay, that's 6. So again, so what do you say? Well, the problem now comes because when we try and carry out the subtraction, we start with our first number. We start with 1 minus 0, which is easy because we get our 1 there. But then we enter this slightly more complicated area where we've got a 0, and we've got a 0, and we've got another 0, and we've got another 0, and we've got another 0, and we're trying to subtract 1 from those zeros. Now, of course, like in traditional arithmetic, we could take the 1 here and we could start to carry a series of 1s back down along the number, but that's really inefficient and would take us ages. So we've got to try and think of a different way of doing it. So that's where 2's complement notation comes in to this. So as we know already, that actually subtracting a number is this, we could actually just add the negative equivalent of that particular number. Of course, 33 plus minus 6 is going to give us the right answer, 27. So what we actually could do is we could try converting our binary number into a negative format. So how does that happen? Well, if we need to convert 6, so that was our 0, 0, 0, 1, 1, 0, into a 2's complement notation, we simply flip the digits. Okay, and we add 1 on. Add 1 gives us 0, 1, 0, 1, 1, 1. Okay, now this number here, okay, does not look like what we might expect it to, but actually this number is now minus 6 in 2's complement notation using 6 bits. And all we have to do is add that number onto our original 33. So let's do that just down here. So 33 again, 0, 0, 0, 0, 0, 1, and we're going to add our minus 6 onto it. So 1, 1, 1, 0, 1, 0, and we're actually on this occasion we're going to add those two numbers together. So 1 plus 0, 1, 1, 0, 1, 1. We have 1 plus 1 here, so we actually end up with 0, and then we end up with a carry bit that we're going to get rid of and throw away. We don't need to worry about that. And of course the answer we're left with here is now 27.